Question 6c, part 2, it says hence or otherwise determine the values of x for which g inverse is greater than g. So we're looking for where the inverse function of g is above the original straight line. So in order to do that, we have to get the point of intersection between these two graphs. And if you recall, the equation of g inverse was a half x minus 5 over 2. We equate this to the equation of g of x, which is 2x plus 5. And if I solve this equation, I'll be able to get the point of intersection between g and g inverse. If I multiply it out by 2, I'm going to get x minus 5 is equal to 4x plus 10. If I move the x over and the 10 to the other side, I'm going to get 3x is equal to negative 15. And if I divide both sides by 3, I get x is equal to negative 5. So this will be the point of intersection between g inverse and g. I can roughly draw the graph of g inverse. We know the y-intercept is going to be negative 5 over 2, and it has a gradient of positive half. So the gradient or the line g inverse of x will look something like this. It has to be an increasing function with a gradient of positive half and a y-intercept of negative 5 over 2. And so my point of intersection is at x equals negative 5. That's somewhere here. And so what we require is where g inverse is above g, and that clearly is going to happen to the left of negative 5, all the way up to negative infinity, and we don't actually include negative 5, strictly greater. So the solution is going to be x is between negative infinity and negative 5.